Hello, my name is Cameron Swen, and I'm the Strategic Marketing Manager for Industrial Control and Automation in the Embedded Group at AMD. Today I want to talk to you about a couple of popular trends in industrial control and automation applications. There are many existing and developing trends in industrial control and automation applications that OEMs and manufacturers alike need to be concerned with. 9 of these trends are efficiency, sustainability, connectivity, security, usability, safety, integration, scalability, and reliability. Automation has enabled factories to operate more efficiently by enabling fewer workers to generate more output. There are less than two-thirds the number of U.S. factory workers today than there were in 1998, but each produces over twice the output than they did then. To stay competitive, systems must increase their output while requiring less operator interaction. The latest generation of high-tech industrial control and automation systems are delivering excellent usability and performance to enable plant operators to push the process, operation, and equipment to its design limits. Sustainability is a complex trend with a variety of influences. According to the International Energy Agency, industrial energy consumption constitutes 30% of global energy use and is projected to increase at a rapid rate. So industry is consuming a lot of energy, and the high energy prices we are experiencing is hitting manufacturers' bottom line. At the same time, worldwide initiatives to reduce CO2 emissions are squeezing manufacturers to reduce their consumption of energy. For example, the International Energy Agency is driving to halve global emissions from 2005 levels by 2050. The combination of these factors is driving manufacturers to reduce their energy usage. To reduce power, systems must not only operate efficiently, but they must be intelligent enough to help the rest of the system to operate efficiently, such as intelligently controlling the torque profile of motors to efficiently spin up to speed, or using variable frequency drives to control motor speeds. Or in industrial process heating, improvements to process control can help reduce energy consumption by keeping the process running at capacity, to minimize storage losses related to cycling a process heating system from off to on. Reducing power in a manufacturing facility involves 4 steps: measuring, visualization, management, and finally reduction. So by delivering more intelligence deeper into the factory floor to continually and automatically monitor, analyze, and report the power consumption of a system, intelligent controllers can help identify problems and make adjustments to help reduce the energy used by a factory. The Internet of Things is driving towards billions of devices being connected by 2020. According to IMS research, this started with the first wave of computers and laptops, followed by a second wave of smartphones and connected consumer devices. The third wave includes those devices but substantially increases with the connection of machines to other machines. This ties into things like plant integration, where everything is being connected and a lot of data is being generated. Vendors are investigating ways to turn that data into actionable information. Systems must be able to manage all of the data and be smart enough to independently, or with minimal operator interaction, act on the data to increase factory efficiency. And a new concept developed by German experts called Industry 4.0 refers to the fourth industrial revolution, which looks at the connected factory and what it is evolving into. The integration of product development, logistics, and manufacturing will be enabled through the flow of materials, products, and information to create highly complex and efficient worldwide manufacturing operations. Where a manufacturing line can be tied into both the supplier and consumption information to dynamically adjust what is being manufactured based on consumer demand and accordingly adjust the raw materials being delivered. Technology is helping to enable advanced control systems on the factory floor to efficiently communicate with one another to manage and analyze the data that is being gathered, and communicate to distributed control systems and enterprise IT networks. This helps to enable plant operators to track and identify areas to reduce idle or downtime, improve efficiency, and coordinate production capacity with demand. In industrial applications, security is becoming less of an afterthought and in some cases a main consideration at the beginning of product and system design. Typical IT security methods are not effective as industrial applications have different priorities. IT security applications generally focus on confidentiality and integrity of data and require high throughput on servers where high processing capability is readily available. In industrial applications, the focus is on human safety and fault tolerance and requires high availability and low latency. All of this on systems that often have limited processing capability available. New security solutions are being developed that are going to benefit both mobile and industrial applications, where limited processing performance is available. For example, in 2012, AMD announced a collaboration to extend ARM TrustZone security technology into x86-based AMD solutions. This will leverage a proven industry security technology into what we call a platform security processor, which will be an integrated coprocessor next to the AMD processor cores. By integrating a hardware security engine into a processor, low-power devices will be able to leverage advanced security capabilities while keeping the system power low and without consuming valuable processing resources. Usability of industrial applications has helped improve the efficiency of factories in the last decade. By enabling users to act on more information quicker and more accurately and facilitate maintenance and troubleshooting. To make these interfaces more intuitive, operator panel OEMs are beginning to implement consumer-like interfaces with gesture-based inputs like those users have already become familiar with on smart devices and gaming consoles. And the potential of analytics, 3D graphics, and video to further increase operator efficiency is only just now being tapped into. But for factories and their operators to fully benefit from the usability afforded by these advanced technologies, they must be consistently implemented in all of the HMI devices across the factory. The scalability of processing solutions that are now available can deliver excellent